Here are two solutions that we are given, and we need to find their pH. One is that of a strong acid, one is that of a strong base. So we do need to recall how these strong acids and strong bases break apart. And so for this first one, the strong acid, we've got HCl. So we know that HCl plus water is going to go fully one way, and that's going to give us H3O plus Cl minus, and our sodium hydroxide doesn't really interact with the water that much, or we don't generally draw it that way. So here it's just going to break apart into sodium ions plus hydroxide ions. And so in this first one, what we want to do is figure out what the pH is going to be. And so we know that pH is equal to the negative log of my hydronium ion concentration. And so since we have a strong acid, we know that the pH is going to be equal to the negative log of 0.030. And when I work that out, I get a value of 1.52 for the pH. That's about all there is to that one. The next one's a little bit more difficult because we've got a strong base. And so we're going to use a method using POH. And here our POH is equal to the negative log of my hydroxide concentration. So that's pretty normal. But then we're going to use a relationship between pH and POH, which is that pH plus POH is equal to 14. And so that'll help ease this calculation a little bit. So let's do that first part. So we've got the POH is equal to the negative log of 0.50. And so when we work that out, we get a value of 0.30 for the POH, quite basic. Now in terms of a pH, what we want to do is then we'll say that the pH is equal to 14 minus the POH, which is equal to 14 minus 0.30. And when that gets worked out, we get a pH that's equal to 13.70, a very basic solution indeed.